dive into code, I'm going to give you an introduction to the problem statement. So what we want to do is we want to write a temperature converter. I want to show you where programming languages differ and also where they don't differ. Where programming paradigms differ, or maybe there's also a way to transcend the difference between programming paradigms. I got this idea because it's part of my study of programming languages. Well, you can't start off with writing a shopping cart application or a pet shop application in those languages. You have to start simpler than that. Because if you don't know a language, you can't create something like a shopping cart application and then do a fair comparison. Because if you don't know a language, you will automatically write suboptimal code. And I think it's easier to learn a programming language by first writing simple programs. So as part of that, I also looked around what programs do other people use when they teach programming. Went to one of the most popular books for teaching programming, the C Programming Language by Koenig and Ritchie. Second listing there is a temperature converter. I looked at the listing and said, that's actually not how I would write it. That doesn't mean that they wrote it bad, but there's a very big difference between writing a temperature converter to teach people about else, or looking at the temperature converter from the perspective of how do you make scalable software design. And scalable software design is something that's always in my head. Ever since I had more than 10 years of experience in writing code, I always think about maintainability. So we want to convert temperatures. So what are temperature scales that you could convert? What temperature scales do you know? Kelvin, Celsius, Fahrenheit, any others? Let's say what Wikipedia has to say about that. That's quite a list, isn't it? So many scales of temperature. That's not even a complete list. Yeah, that's just the most popular ones. We have Celsius, Fahrenheit, Kelvin, Rankine, Delisle, Newton. Wait, Newton? Yeah, that's not just a force, but Newton also came up with a temperature. Yeah, so degrees Newton. Yeah? Then Mu and Römer. I hope I pronounced them correctly. No guarantee for that. So quite a number of temperature scales, and we will want to write a converter that can deal with all of them. And of course, we'll start small and easy, yeah? But you can already start thinking of the challenges that a piece of software would face when you try to write a converter that converts from each and every scale on this list to each. Then let's get started. We want to write a temperature converter, and we want to write it in TypeScript and Kotlin. So let's start with TypeScript, okay? And so what's the first thing I should do? We need to agree on an interface. So let's write a quick README file and say temperature converter, say user interface, and say we have a CLI. And when we say node tempconf.js, then they see f 0100, then that should print 32.0 and 212.0. Okay, so that's the interface. So we give as the first command line argument the source temperature scale, as the second command line argument the destination temperature scale. That means the way how we are running the program. Here in this case, we are converting from Celsius to Fahrenheit. And then we give any number of temperatures in the source scale. In this case, in this example, I'm giving 2. And then each of them will be converted to the output temperature scale, in this case Fahrenheit, and printed. That's the interface, okay? By the way, the interface is kept intentionally simple, not just for the purpose to fit it in a meetup talk, but for a Unix environment, that is how you define or design command line interfaces. You don't want that you then have additional stuff here. Like, for example, I could print the unit in the output, but as soon as you want to process the output further, that just gets in the way. So keep things simple. Any questions about the user interface? And for Kotlin, that of course then would look very similar. Yeah. And then would be Kotlin temp.conf kt. And that's the only difference we would expect between the Node and the TypeScript and the Kotlin versions. Okay. Any questions at this point? Okay, then what should be my next step? What should be my next step? Then let me just do something and you can say whether that's right or wrong. So let's say we do a temp.conf.ts and then process.out.write. Hello. Obviously, hello is wrong, yeah, but just to get this started, and then let's try to compile this. And cannot find name process, install type definitions for Node. Yes, we want to do that. So let's do that. That should create a package JSON. And then let's try to do this again. And then let's try to run this. And it prints hello. Yeah. But maybe not in the nicest way. Let's add a new line character here. Oh, works. So then we want to convert, right? So I think process.argv was it, right? If not, the compiler is going to tell me. That's our, now we need to find the formula. So let's look at this here from Celsius to Fahrenheit. That's our formula that we have to apply. That is my Celsius value. I want to multiply and divide and plus. We could write a function, yes. What would be the name of the function? Just convert, okay. Should we use process.rb in the function? No, that doesn't feel right, right?
Yes.
Process.rb should only be used in the main program, not inside any function. So we want to take a parameter here.
Just in the chat, you could work since this is the
That's better, yeah. Convert actually Celsius to Fahrenheit, right? Convert Celsius to Fahrenheit. and that should be process.rb2 if I didn't do anything wrong, and then that is the result. And let's see what the TypeScript compiler says. I actually would like people to protest, but they don't. What would I like you to protest about?
So the function name need not have the different scales, because we have passing the scale problems.
Okay, that's a design discussion to have. Yeah, that's not necessarily the protest. When I say protest, then that should be something where we should be able to objectively agree whether it's right or wrong without needing to have any further discussion. Yeah. Oh, of course, you can also disagree with me on design. Yeah, and of course, I will happily entertain that because that's why we're here. Yeah. So I hope that we are going to have some good discussions about design. But there, you should find something questionable about my approach.
It's good.
We should give mentions to different design in the chat.
Let me see in the chat. Didn't define results. I think it's defined now. Yeah, originally I didn't, and then there was even protest by the TypeScript compiler. But now, when we run the temperature converter and CF32, let's see, yeah, none, not a number. That's not what we expect, right? There must be something wrong with the program. Still no protest. I think Anand said
It's taste.
exactly. Anand said it.
Somebody else would say that.
Yeah.
Also, had we assigned type, then my TypeScript compiler would have had something.
Yeah, it would be better to actually have types, yeah, and that they get not a number is because we are in TypeScript and I have a string here, yeah, and then I'm trying to multiply a string. Yeah, JavaScript would happily do that, but not TypeScript. Yeah, so that's why we get another number. But before all of that, tests. Yeah, I should first have tests. In this case, I don't even need a unit test, and I actually don't want a unit test. Yeah. I think the word unit test is misleading because it makes people try to test as small portions of their software as possible. And while that is done with good intention, I think it's the wrong approach. There's one thing I like that you get from small tests. That is the test execution speed. But it's really the test execution speed that I'm interested in and not the actual granularity of tests in structure. Now, I'm interested in tests to observe behavior or to actually know as little about structure as possible. Because when I change structure, how do we call that when I change structure? It's refactoring. When I do that, I don't want to have to touch my tests. When I have to change my tests a lot when I refactor, then my tests get in the way of refactoring. They create resistance to refactoring. If the system is big, it can even lead to conversations like this production code is bad, shouldn't be refactored. Yeah, we already thought of that, but then we didn't do it because of the tests. If that is the situation, your tests are really too tightly coupled to your production code. I want tests to operate on very nicely defined seams, on surfaces where change is either predictably not likely to happen, or where if change happens, it's at least going to be cheap. A lot of the stuff that we do is about the cost of change. And also when we look at why do we want scalable designs, that's about the cost of change. We want to keep the cost of change low. So I'm not going to use any unit test framework in today's session. I'm just going to say, okay, if I call a program like this, what should be the output? I'm just going to put that in a Makefile. So say my old target, that's the typical target you put in a Makefile where you say that is the stuff that you always want to do most of the time. And then that's test. And for test, I need my TypeScript file to be compiled to my JavaScript file. And then I have to tell it, so how do I actually compile a TypeScript file into a JavaScript file now by calling the TypeScript compiler on that file. And then it's also good to have a target to clean stuff. So in this case, I'm just going to throw away all JavaScript files. That's for cleaning and running the tests. Yeah. So we say if I run my program with 0 and 100, then let's do some test design. Let's say the points with which we test the program, the temperature points, are the absolute 0, the freezing point of water on Earth's surface pressure, and the point of water on Earth's surface pressure. Then that should be, yes, very good. That is the benefits of pair or ensemble programming. Thank you. Then that should print something. Yeah. Right now, I don't know what exactly it should print. I can just take these values, and here in this case, luckily, we have we can just ask another system for the answer. I can just ask Google, and Google says it's minus 394.87. Okay, let's put that there. Then 0 degrees Celsius in Fahrenheit is 32, and 100 degrees Celsius in Fahrenheit is 212. And we have new lines in between. So that should be the same. So that's my test case. It's not perfect. I'm not doing any testing about non-numbers. No, I'm not going to do that for the sake of time. For real production code, of course, we would be testing that. But that should serve as a nice test case. And then also, it's going to be much faster turnaround times. We'll then just have to type make. And now I have to fix this. So how do I convert in TypeScript from a string to a number? Who remembers? Yeah, I have to call parse float, right? To call parse float.
If you have any testing, it will not have written test, but somebody will have said part in, because in the beginning fact we were already in the integers. But only when we wrote the test, it was clear that
and still giving them a number. Let's see what happens when we say temp as number. Let's start using the features of TypeScript. See if the compiler finds an error in this. Still says not a number. So any idea why this still gives not a number? Let's try this.
Then the automatic rule is not a number, it says like either C or I.
If you print R
Yeah. Yep. Oh, let's just print them.
Yeah.
That's of course the wrong output, but after that we're gonna see what we are getting as the arguments there. F and then the number. It means actually 4 is the first number. So too many other things going on the command line before that. Okay, that already looks better. Yeah. The first line now is correct. Yeah, it's just the other 2 lines. So let's try this. Yeah. And if you see I'm using TypeScript wrong, then just immediately shout. I might occasionally do burden switching a lot between different programming languages. So I'm, for example, not sure about the length thing there. If you already know it's wrong, then please say something. No parentheses. Okay.
and the process, print should be the
Oh, yes, the print should be in the loop. Ah, very good. Yep, absolutely. Okay, we get the output without the dot zero. In that case, I'm just going to change the test. Yeah? Whether that's with dot zero or without dot zero, that doesn't play any role for us at the moment. Yeah? We don't need to be picky about that. Test passes. We got our first test case passing, right? So test case passes, that's cool. And then let's look at our code. Yeah. Obviously, this program isn't correct. Yeah, it just is behaving nicely by coincidence because the user asked for Celsius to Fahrenheit, and we're always doing Celsius for Fahrenheit, so this time it matched. We have to support the other scales. Yeah. So, but before I go there, let's also do it in Kotlin. Yeah. So let's do the same thing. This case, let's just change the directory structure here a bit, and the temperature. But TypeScript and make a new directory. Temperature converter. Move the TypeScript directory into the temperature converter directory. And then make a Kotlin directory there. And then I can just Makefile from TypeScript directory and change it to whatever we need. We need a temp.conf.kt.class file. That is what we execute with the Kotlin command. Class comes from KT, and we need to call the Kotlin compiler for that. And we want to leave all class files and recursively the meter in the directory when we're cleaning. And right, that already tells us that there is no rule to make temp.conf.kt.class. So let's create the temp.conf.kt file. And just put a print line there, and that should tell us whether our Makefile is working. And yeah, I have to put this in a function. I could have used Kotlin script, then I could be outside of the function. But I don't get any benefits from using Kotlin script for this problem statement. And then we can say we have arguments, args, and you can also make a function converts Celsius to Fahrenheit. And we need that formula. This formula. So let's see what that does. Obviously, we're still missing the loop, but other than that, that should work. Yep, first temperature is converted. Test only says the second and third are still missing. So now let's just loop. I forgot whether Kotlin supports slices. Yeah, I just used the slice, hoping for the best. Oh, it doesn't.
I think it's the semicolon at the end of the written line.
Come again? It's
The next semicolon at the end of the written line.
no. The complaint definitely about this here. Yeah. Look at the error message says expecting square bracket at that point. Yeah. So that means I have to get my arguments in a different way. Don't remember whether it was drop or skip. How that directly connects with what I already said earlier. We are, as an industry, we are unable to agree on vocabulary. Yeah? Look at sequences in Kotlin versus streams in Java versus whatever Python does versus whatever other APIs do. Yeah. Sometimes it's always called reduce. Sometimes it's always called fold. Sometimes it's called reduce when it's monad and fold when it isn't, or the other way around. Can't remember which is which. We are unable to agree on our vocabulary. I look at link in C#, again, same stuff, but named differently. That's would be nice if we would manage to agree on a vocabulary. As
I agree on putting the basis on the same line on the next line.
Even that we can't agree. Yeah, I mean, I have an opinion on that. Yeah, I prefer to put the brace at the end of the line because I think that it's an unimportant thing and it shouldn't waste screen space. But when I write C# code, I put the brace at the start of the next time because that's how you do it in C#. And I think it's more important to be consistent and follow a convention, even if I don't agree with everything of a convention. But there's value in just following that convention. When somebody reads source code, they shouldn't be negatively surprised. Yeah. Whatever they read should be pretty much what they expect. Yeah? And when there is something unexpected, then the surprise or astonishment that comes from the unexpected thing should be positive. Yeah? It should be like, oh, that's a smart way of doing that. I didn't think of that. Yeah? But of course, that's something you could only say if it was still understandable. Yeah? Shouldn't be like, I can't figure out what that is. Yeah? So now we see that here in Kotlin, we get the result with .0, and that's again a difference I'm going to ignore. Also, we're just going to update the test and say here the output is with .0, and then the test passes. Is there any fundamental difference between our Kotlin version and our TypeScript version so far? Hold on, that's the compiled one. Is there any fundamental difference? Right now, not yet, right? I mean, whether I use MapReduce or a loop, that's a bit of a difference, but I wouldn't call that a fundamental difference. You know? I can always take a loop and a recursion and a MapReduce and find a way to translate between those three. If I know how, I typically prefer MapReduce because I think it's the more declarative way of expressing myself. It's more abstract. And because it is more declarative, more abstract, it gives the underlying execution environment more potential for optimization. Yeah, whereas if I go bare metal and write a loop myself, yeah, then the execution environment doesn't have any ability of easily optimizing, yeah, like using parallelism. In Java, for example, you have parallel streams. And if you have a thread pool executor in your threads context and you use a parallel stream, then it will automatically parallelize the work and utilize the cores available to the thread pool executor. That's pretty cool stuff. I don't have to be worried about anything about that. I can delegate such things to the execution environment, which is one of the reasons what makes Java such a fast language today. When I started with Java in '95, it was the slowest possible language you could imagine. It's slower than everything else around. Yeah? Python was still around already. Was already around. Python is much older than Java. I've been using Python before I've been using Java, and Java was slower than everything. But nowadays, Java is one of the fastest languages. There's even stuff that is faster in Java than in C++. Not that the language itself would always be faster, but the way how the optimizer works. Yeah? The optimizer in Java is running at runtime. Your program is compiled to bytecode, and then when the bytecode is interpreted, the just-in-time compiler of the virtual machine is profiling your code as it executed, and then using the information from that profiling to decide how to optimize the machine code after compiling the bytecode into machine language. That gives it a benefit over typical C++ code. Yeah? Most C++ code is actually not using a profiler. It could, yeah, the new profiler is available to the charge. Most people sadly don't use it. But no fundamental difference yet between TypeScript and Kotlin here, right? What's the next thing I should do?
We should generalize instructions for other solutions.
Yeah, we should generalize this. So what do you mean by generalizing this?
We should not only convert censorship to binary, we should convert other.
Yeah. So how shall we do that? Then what are the different building blocks that we need in order to get there? One building block is obviously we need those other formulas, right? And another building block is we need the mechanism for selecting the formula. Yeah. So where shall we put what? What do you suggest? You can keep on suggesting. Yeah, you seem to have already something on your mind. Just keep on.
Yeah, like first thing is we have to change the name of our function.
Okay, what should be the name of our function?
Convert definition.
Okay, let's go there. Let's do that.
Yeah, then we can also take, so right now we are also taking variables to convert. Like C and P out. So we can access them and then on the basis of that we can perform the operation.
Okay, so you suggest that we basically give this convert temperature function 2 more arguments, right?
Yeah.
Okay. So that means like the input scale and the output scale, right? And that means when we call this, this has to be process argv2 and process argv3. And here,
Another option we could keep the functions as is, as they are your functions, write another function for each of those conversions, and then have a wrapper around them.
and let me continue this step and then we go for the other step, okay? Because I think they can be both combined, okay? So string is uppercase in. Yeah. I'm not using input scale and output scale yet. Yeah? I just want to see if the change that I made already works. Yeah? I could get the compiler telling me you're not using input scale, you're not using output scale. But that should be the only error that I'm getting. Yeah? The test should still pass, right? Yeah. So let's check that in Kotlin. And maybe let's just make 2 windows. So I can work on both languages in parallel at the same time. Yeah, that looks good. Yeah, that's exactly what we predicted. And let's do this in TypeScript. And yeah, perfect. TypeScript just passes. Yeah, would be nice if the TypeScript compiler would have told me that I'm not using input and output there. But that other than that looks okay. And yeah, then there was a suggestion. Let's keep the functions because they're pure functions. They're tiny, simple functions. I can do that. I can just put convert Celsius to Fahrenheit back here. And then here return convert Celsius to Fahrenheit. Yeah, that's of course it's not entirely correct. Yeah, we know we will have to inspect those strings, but I like to go in tiny steps because when I go in tiny steps and something isn't working, I know immediately what's broken. I know it's my last change. But it's always the last change. The question is, what's the size of the last change? Is it 5 minutes or is it 5 days? Yeah. So definitely prefer to go in small steps. And then here, that actually is not a Celsius here, that is just a temperature. So let's just call it temp. And let's see if that is working. Or if I did a mistake. Oh, yes, in Kotlin. Seem to have a mistake somewhere. Yeah, that's an S missing in Celsius. Okay. Cool, that works. Then what's the next change that you suggest?
So on the basis of input scale and output scale, we should perform that operation.
Yeah. Which means basically we want that if we have an unknown input scale and unknown output scale, that basically also should maybe throw an exception or abort the program or whatever. Yeah. So I'm putting the if else there, just the if for now. And wait a minute, I think I already see a mistake in the Kotlin. That has to be a double quoted string, because in Kotlin single quotes is characters. Okay, is this going to compile? Yeah, this is going to miss a return statement for the if not taken. Yeah. Let's see what the compiler says. Yeah, in TypeScript that happily compiles, and I think it shouldn't, but it does. I'm here totally with the Kotlin compiler, but I'm not faulting TypeScript. Yeah, don't get this wrong. Yeah? TypeScript shouldn't be judged by the things it doesn't do compared to something like Kotlin. TypeScript should be judged by the things it does do compared to JavaScript. Yeah, and by that, TypeScript is really good stuff compared to JavaScript. Yeah, so cool. We know that our program is incomplete. What should we do if we do not take the if? What should we be doing?
We should go here right now.
Yes, we should throw an exception. Yeah. There are people.
You can also return arbitrary double just to indicate it's an error situation rather than doing that.
Yeah, but how does the caller know that this double value means an error? What happens with the caller if the caller forgets to do that? Yeah. Right now, because we're in an if situation, it's pretty obvious. Yeah, we should do something like throw new, no new, we are in Kotlin, throw illegal argument exception, unsupported conversion from input scale to output scale. Yeah, that's what we should be doing. Yeah? If we would have approached the way how we phrased code slightly differently, we could also be in the following situation that we say outputs temp as a double, and then here we could have output temp equals, and then return output temp. Yeah, that's also how it could be phrased. And if you follow structured programming very strictly, that's how you would phrase it. I don't like to follow structured programming very strictly. What do I mean by this? Yeah, when you follow structured programming very strictly, You want that you really have a nested block structure representing every program flow, every direct transfer of control, so from one statement to another inside a function. To be really a nested block structure, that means your function should have only one return, and that return should be at the end of the function. I agree with that in spirit. Yeah, but the problem with early returns is not in functions that are 5 lines. The problem with early returns is functions that are 100 lines. If you have a function with 100 lines, the return is right in the middle, and you read the function, you just might not see it. Yeah. I don't have a problem with early returns and functions that are just 5 lines. Because you see the return statement. If it's just 5 lines, you see it. There's nothing to not see. And my beef is much more with long functions anyway. I don't write functions with 100 lines. So the size of function that I have, I'm completely okay with early returns. Yeah.
But I would prefer having return statement if there are multiple ifs. So for example, in here,
Yes.
if there are 5 more ifs,
Yes.
and we are changing output temp, we are assigning output temp in each if,
Yeah.
then I think it would be easier to return in each if, and it would be more readable than going through each if case, and when what is the output temperature where it is changing, finding out that instead of that returning is much easier.
Exactly. I fully agree with that. Yeah. You've said what I planned to say next. You said it perfectly well. I don't need to add anything. The early return makes this type of code more readable.
Yeah, instead of if statement, we can also use switch case order.
We could use switch case. Yeah.
It will be more readable than this.
Could be more readable, or in Kotlin it would be when. Yeah, but could be more readable. But I quickly want to show you something else about a typical error situation that here happens. I basically avoided it through the early return. Yeah, I'm currently introduced this variable output temp just to show you what problems I see when I review code in organizations. So what's the compiler gonna tell me about my code here? The compiler is going to tell me that output temp is potentially uninitialized, right? Because if the if's not taken, output temp is not initialized. Now let's verify that. And we see variable output temp must be initialized. That's the problem. And then what I see people doing is the following. And that is dangerous. Yeah? That is dangerous. That is exactly to what I already mentioned a bit earlier. Yeah? And we have now a function convert temperature that in the case it didn't work properly, pretends to have worked properly, returns a value that is wrong, and the program now continues with a wrong value. Yeah. There's a rule of thumb that I first read in the book The Art of Unix Programming by Eric Raymond. The title is potentially misleading because it's not targeted towards people who program on Unix, but it's targeted towards all programmers, and it teaches you what you can learn from what people experience when developing Unix. And the rule in that book, or one of the rules, is that a crashed program does less harm than a crippled one. And right now with my initialization, I've crippled my program. I've also crippled the mechanism of the compiler to tell me that a branch is missing. So that's the dangerous thing, but we already discussed that we actually want to have an early return, that is the most beautiful thing to do here, and then throw illegal argument exception with unsupported temp scale, unsupported temperature conversion from input scale to output scale. Would be nice to know which of the two was wrong, but right now our structure cannot yet give us that information. So let's see what the compiler makes of that. If this were production code, I would now also test for the error. Highlighting that for production code, I'm just not doing it for the sake of time. So that's fine. What should we do in TypeScript? How do I do a string interpolation in TypeScript? I need the backticks, right?
Yeah.
Not the
That's not testing, but the error comes. It's just testing whether that line compiles. So it does. Cool. Let's just see this at least once. Node temp.conf JS foobar. Yeah, unsupported temperature conversion from foo to bar. That error message works. KT is missing. Yeah, same. Works just fine. Obviously, we shouldn't still take stack traces to users. Yeah. So for a real program, there should be a corresponding error handling in the main function. So we got our if in place. Yeah. So what's the next step? We could add Fahrenheit to Celsius, right? Then let's do that as the next step. So we need a convert Fahrenheit to Celsius. And we need to trigger that if input scale equals F. Very good. Very good. Very good. We should have a test first for that. For this, we really should have a test. So let's add the test. I'm just switching off the syntax highlighting because I think that makes it easier for you to read the text. And we can just reverse the values here. 207, 5, and 0, and 100, and F to C minus 394.87, and 32.0, and 212.0. And the same thing here. Seven and 32 and 212. Great, and now I can go back here and we already know that test is red, so I don't need to see the red. I know that the red is there. Convert Fahrenheit to Celsius. That's an interesting thing. Look at this and think, what is this? why am I getting that odd number? Any idea where that is coming from? There's a fucking Makefile. Yes, in the Makefile, I forgot to swap C and F here. And I'm getting the same odd number in TypeScript. What's that odd number?
Floating point errors.
Mhm. That's a floating point error. What are floating point errors? Where are they coming from? What does this mean?
It's specific to the right-sided point. I get it.
Let's do something similar along the lines. I'm now in the J shell, in the Java interpreter. When I type here 1 + 2 = 3, this is going to evaluate the expression and tell me the result of that expression evaluation. This is a Boolean expression, right? Left side compared with right side. That's going to tell me true or false. What are you expecting here? True.
True.
True. I expect true here. So let's see if it really comes true. And yes, it does. Yeah. Now let's change this expression a little bit. What do we expect to be printed? Yeah. It's not going to print true.
All.
This is going to print false. It is not wrong that you expected true. It just means you haven't encountered this issue yet in your life. When we are dealing with floating point numbers, in most programming languages, they will be stored in the IEEE 754 format, which means that the floating point number is represented a certain number of base and a certain number of exponent bits. And the base bits, they represent fractions of 2. So 1, half, quarter, eighth, 16th, 32th, and so on. And that means when you have a decimal fraction like this, that cannot be represented with a finite number of additions of distinct negative powers of 2, then you automatically have a rounding error. That means basically you always have a rounding error in a float or double number, always. So exception is if I say 0.5. Yeah, if I say 0.5 plus 0.25 equals 0.75, that's going to be true. Yeah? Because now my floating point number is really purely made of negative powers of 2. Yeah, 0.5 is 2 to the power of -1, 0.25 is 2 to the power of -2, and 0.25 is the sum of those. That can be precisely expressed in a float or double. Therefore, when I add this is true. But in the other, there's rounding errors. And that is exactly what you see here. Yeah? You see a floating point rounding error. For this reason, yeah, you're not supposed to use float and double to represent monetary values in software. It's actually illegal to do so in almost every country. Yeah. It violates what we know as GAAP, the generally accepted accounting principles. Now, that's the principles that accountants have to follow for mathematics in financial bookkeeping in companies, and all numbers that are calculated to contribute to that have to follow the generally accepted accounting principles. And the rounding rules of generally accepted accounting principles are not satisfied by the IEEE 754 standard for float and double. Was never meant to be. Float and double were not made to represent monetary values. They were made for engineers. What's the IEEE? It's an engineering organization. Float and double are engineering types. You can calculate the float and double and safely hit Mars. That works if you take care a little bit. But don't use them in accounting. If you do so and an auditor finds out, someone will be held responsible for that. And scientists also often do not use float and double. Instead, scientists use other types or other libraries that operate on other types. So that's about float and double. We're going to come back to float and double because it's going to hit us again. For now, what I'm going to do is I'm just going to change the Makefile and say we don't want to deal with this at the moment. I will simply replace the expected value and say we accept that we are dealing with float and double at the moment. And now the test passes. That's our software at the moment. Any questions? So right now we're supporting 2 units, right? Celsius and Fahrenheit. What should we support as the 3rd unit? What do you suggest? Kelvin. Okay. How many functions do we need to add if we want to add support for Kelvin? 4 more functions, right? 4 more functions. Celsius to Kelvin, Kelvin to Celsius, Fahrenheit to Kelvin, Kelvin to Fahrenheit. 4 more functions. How many if branches do we need to add? 4 more if branches. Now let's pretend we already implemented Kelvin. And we now want to implement a 4th scale. How many functions do we have to add? Let's say we want to add delay. Then we have to add 6 more functions, right? Delay to Celsius, Celsius to delay, Fahrenheit to delay, delay to Fahrenheit, and Kelvin to delay, delay to Kelvin. 6 more functions and 6 more if branches. Does that scale? No. No. Well, it scales, but when we say it does not scale, what we actually mean is it scales in a way that is larger than linear. How does it actually scale? Let's look at how that actually scales. If we have all of them, then we can actually make a nice graph of that. Every unit that we want to convert is a node in the graph, and every conversion function is an edge. And it's actually bidirectional because we can go from and to in all directions. So how many edges do I actually have in this graph? Yeah. What's the number of edges in this graph? Let's find a way how to count that. Yeah? I can take one of them and say, okay, I have incoming from all of them. So I have 1, 2, 3, 4, 5, 6, 7 incoming. And that's on all of them. So that's 7 into 8. 56. 7 into 8. There's also another way how to count it, which in the end will lead to the same formula. So I can say, from here, I go to R and I go back. That's 2. That's 2 into 7, so it's 14. Then I count for them, that's another 14, but it's actually 2 less because I don't want to count those double. Yeah, so 14 plus 12 plus 10 plus 8 and so on. You end up at the same number. Now, what's the formula for that number? Any idea?
And to the power 2 minus 2 is 2, yeah.
Almost correct. Just the word power. Remove the word power.
N into n minus 1.
Exactly. It's n into n minus 1. Yeah. Because so the number of edges in a fully meshed graph is n into n minus 1 divided by 2. But we are walking all edges bidirectional. So we have to multiply that by 2. So that is effectively n into n minus 1. What's the complexity of that? What's the complexity class? Exactly. That's O(n) squared. That's not really sustainable from a design perspective. Our code would become more complicated with every additional conversion that we want to support. Or in other words, what is the effort of adding one more conversion unit? Yeah, that's O(n). So the n minus 1, yeah, but in complexity constants, just remove them. What can we do to counter that complexity? Any idea? What do you suggest?
The way I see it, make it reactive. Like listen to the changes in the scales we want to measure. Instead of computing everything entirely, like if the inputs are changed from Celsius Fahrenheit or to Fahrenheit or Celsius, each function will be responsible to listen to that change and calculate it.
But then we still need that number of functions, right?
Yeah, but we can get rid of the if statement.
We could get rid of the if statements. Yeah. So that means there are certain things that we could do right away in order to reduce the impact per n. Yeah. Basically, this n is always multiplied with a constant, and you always add a constant, and we have influence over those. Yeah. So when I look at the source code, what I definitely can do is I can say, for example, let's make a map where the key is a pair of two strings and the value is a pointer to the function. And then I just have to get my entry from the map. If I don't have one, I throw the exception. Otherwise, I call that function. So I can, by this, make the constant by which I multiply my n square smaller. Yeah? And we should certainly do that. But it does not remove the n square part yet. Yeah? I'm also looking for a change to the design that is removing the n square altogether.
It's a design problem. That's solving the design pattern.
Come again?
That's solving the design pattern.
Which design pattern?
You can see a factory can be implemented here, factory pattern, which will give you essentially the function based on.
But you still need the factory to know that many functions, right? Yeah.
It's just removing the if file.
Yeah. So there are certain design approaches, yeah, and you can call them design patterns. For example, what I said before, what you called reactor-like design, I would have used different vocabulary to describe it, but it most likely mean the same thing. I would have called it strategy. Yeah, but how you call it doesn't really matter that much. Yeah, I mean, names for design patterns are useful because if I say strategy and you know strategy, we both immediately know what we're talking about. That's useful. Yeah? It's just like if I say chair and you say chair, and we know we both mean chair. We know what you're talking about. It's useful. Yeah? If I say Stuhl, how many know what I'm talking about? Some might even have bad guesses. They might be guessing in the wrong direction. Yeah? Stuhl is simply the German word of chair. Yeah? But then you wouldn't know. So that's something that I find very useful about this, design patterns. Yeah? And don't listen to those people that say if you use functional programming, you don't need design patterns. It's rubbish. Yeah? They say you can replace all the design patterns with higher order functions. That is a wrong statement. The correct statement is all these design patterns are demonstrations of how you can use higher order functions. Yeah? And whether you call it polymorphism or higher order function, doesn't matter. And you still have to do something like strategy if you use functional programming. And it still makes sense to call it strategy. It doesn't go away. Yes, some design patterns, like, for example, the builder pattern, not how it originally was meant to be used, but how it then often is used. That's just boilerplate to compensate for deficiencies in the language. As if you look at most of the builders in Java, they actually just compensate for the fact that in Java, you do not have named parameters with default values. Yeah? So sometimes design patterns are really just workarounds for language deficiencies. But in other cases, like strategy or composite, they are just representations of the natural world.
So I think in this one, probably we can, since we want to convert with bidirectional, right? We can always introduce just one parameter saying reverse and have the function to the reverse to the same. It will reduce.
Well, it will have it. Yeah, that's basically n squared divided by 2. Complexity class will still be n squared. What do you suggest?
Instead of graph, can we use object of graph? Their value.
Well, it's still, so when we look at the picture, yeah, so most suggestions we've been discussing so far, what they are is, they are suggestions to make the number of edges more manageable. That is a good suggestion to do. But what I'm looking for is a way to reduce the number of edges in the graph, right? That's what the n square means. The n square is the number of edges, and I want to reduce the number of edges. Any suggestions? Yeah.
What if we have 10 functions? In this case, so maybe we can have one base scale. And then
Exactly. Yeah. So basically, we want to change the shape of the graph in the following way. We still want that it's possible to navigate from every node in the graph to every other node in the graph. But we want fewer edges. Yeah? That means we will no longer travel directly from every node to every other node, but we will travel through one other node. We will change the shape of the graph from a fully meshed graph into a star. Yeah? We put one unit in the center. Yeah? And which unit should that be? I mean, the answer is already here, but why is it that unit? Because that's the scientific scale. Yeah? All other scales are regional scales, and they all have been redefined as something based on the Kelvin scale. Yeah? They've all been redefined. Celsius was originally defined, where we say 0 degrees Celsius is the freezing temperature of water at 0 meters altitude on the Earth's surface. I think they even specified where, equator or something like that. And 100 degrees is the boiling point. That's no longer how it's defined. It's now all defined based on Kelvin. Kelvin is defined via Boltzmann and so on. So Kelvin should be the central scale. Then our graph becomes a star. Yeah? We no longer can directly convert from like Celsius to Fahrenheit. Yeah? We have to do two conversions. Yeah? We go from whatever we have to Kelvin, and then from Kelvin to whatever we want. Yeah? So that means now, what is the number of edges in this graph?
Two into n minus 1.
2 into n, so 16. Yeah, with 8 temperatures, and we also, I mean, those two here, those two arrows at K, from K to K. Yeah, they are Kelvin to Kelvin and Kelvin from Kelvin. They are the identity operation. Yeah? But it makes sense to still have them. Yeah? You will let us see why. So that's 2 into n, so 16. What's the complexity class of that graph?
U of n.
That's O of n. So we got rid of the n square. So the overall complexity is n. It's much more sustainable. That scales much better, right? And what is the effort of adding another scale? That's now a constant effort. We just need to add 2 functions. For every new scale, exactly 2 functions. It no longer depends on the size or complexity of the existing system. We have the effort OC that now scales, right? So that's where we want to go. Any questions at this point? Cool, then let's do that. Basically, there are different ways of how you can see that we would actually have to go in that direction. Another way how you could have discovered that by looking at your code is, and sometimes you see that earlier, sometimes you see that later, but usually there will be a moment where you see that is that we are always comparing 2 things in our if statements. Yeah? So what if we could get that down to only 1? So basically what we are also doing is we are separating our if statement, the left side of our ifs, which is looking at the input scale, and the right side of our if, which is looking at the output scale. Now we're separating those things from each other. And of course, we want to get rid of the if statement. By the way, the if statement is violating a design principle. Which design principle is violated by the if statement?
Open close principle.
the OCP, the open closed principle. Whenever we add another temperature scale, we also have to modify existing code. And whatever you already suggested, like using a mapping algorithm or mapping structure to do that, would get rid of that problem. So the OCP is violated. Cool. Now let's do that. Yeah, that means we actually don't want to go from TS to Fahrenheit anymore, at least not directly. We need this table, which basically also means when you look at the Wikipedia page, instead of implementing all tables, we implement only one. We implement only this Kelvin table. So Celsius to Kelvin, that's the function we want. That's an easy one. And then what changes here? Let's not remove the if now. Let's just change the code here, separating the if, the left half and the right half, and then put the things in the map later. So we want to say that we get an well, Kelvin double, then if input scale equals C, we say Kelvin is convert Celsius to Kelvin of the temperature, right? And then we need the same thing for Fahrenheit. Convert Fahrenheit to Kelvin. It's this formula. From Celsius to Fahrenheit and Fahrenheit to Celsius, I can just remove them. That's the new convert temperature function in Kotlin, right? We need one more function here, convert Kelvin to Fahrenheit. With this formula. And if I didn't do anything wrong, then that should already work, right? Okay, while the compiler is working, I have another question for you. Yeah. So when we do this design change, what's the impact? Yeah. We know the impact is that our code has become more maintainable. Yeah, because that scalability that we're looking at is maintainability. A certain aspect of maintainability. How much effort is it to support another scale in the code? Are there any other consequences of making that design change from the fully meshed graph to a star graph? Are there any other consequences? What do you think?
More computation.
Exactly. Yeah. More computation is needed. Instead of going through one temperature conversion formula, we're now going through two. We're always going from here to there. Yeah? The only situation where the number of computations stays the same is if the input or output is Kelvin. But if it's any of the outer nodes of the star, then we now have to go through two formulas. What's the impact of going through two formulas? There's a performance impact. Well, in this case, it's probably negligible. We should be aware of that. Is there any other impact besides a performance impact of going through more formulas or more arithmetic operations? Let's see. Oh, return expression required. I did a boo-boo here. Line 33. Yeah. That's right. Return output would have been nice at the end of the function. So let's see what the compiler says now. Well, Kotlin and TypeScript are both among the slowest compilers that I know. Ooh. I must have done something else wrong as well, and I did. Yeah, here that has to be Kelvin. Yeah. That error could have been prevented if I wouldn't have written such big functions, but I would have already separated those two things out into separate functions. And what is that? Do you see now? What is that?
Precision.
Precision. Yeah, the precision bites us again. Yeah, we here and see the problem that because we now have increased the number of operations, the precision is reducing. Basically, every single arithmetic operation that you perform on a double is reducing your precision in the worst case by 1 bit. Yeah. And because now the number of operations increases, the number of faulty bits also increases. And what you see here at the end, yeah, that's basically the result of faulty bits in the float or double at the end of those numbers. What can we do with this? I mean, if we look at the number overall, it's still pretty close. Yeah, it looks weird, but if you look at this from the perspective of how precise is that actually, yeah, it's still pretty close. And what you typically do in such a situation is you choose an output format that will perform rounding in the presentation of the number. And if you're using float and double in science, what you typically do is, so first of all, in science, often your input numbers already have much less precision than float and double would actually give you. So you already know that you have a certain error in your input values, like how precise is your thermometer, for example. It doesn't have infinite precision. And so you actually have to understand, just based on your input data, what already is your error. And you also have to, you then simply make sure that the error that you get from your floating point operations, based on the complexity of your formula, will always stay below the error that you already have from the precision of your input data. And then just format it on the size of the input data. So we are also just going to fix this by applying some formatting here. So instead of using print line, we're going to use system out format. And we're going to format this with %G, %N. And then let's see what the test does. We're still going to have to change a little bit, but you're going to see that change is going to be much more sustainable. Yeah. So you see now with %G, I have 6 digits precision, 6 decimal digits precision in the output, and that's something I can deal with. So we put all of these onto 6 digits precision. And same for those. And then let's see how it passes. This is very similar to when if you've ever used unit test frameworks and used assert equals in a unit test framework, yeah, like in JUnit, for example. Your assert equals for double actually takes 3 parameters. Yeah? The first double value to compare, the second double value to compare, and then a delta. Yeah, mathematicians would call it epsilon, but epsilon delta, who minds which Greek letter it is? Yeah? It's the amount of precision that you expect from the comparison operation. What it actually does is subtracts the 2 values, takes the absolute of that, and compares that absolute is less than your precision value. So with that, it passes. So that's our change in design to the one in Kotlin. And now let's do the same thing in TypeScript. Yeah, just gonna be lazy, just gonna copy those and translate them to TypeScript. That should already be it for the functions, right? Same change here. I can still just go peek here. Copy the Kotlin code. Anything else I need to change for TypeScript? Yeah, let's see what the output is going to be with the numbers. Yeah, the remaining question there. What do you suggest should I do in TypeScript to deal with precision? Any suggestions? And I could put these numbers in my test. Yeah, I could say these numbers are good and put them in my test, but I don't want that. Yeah. Because as soon as I change something about formulas, I could have to change my tests again. I don't want that. I don't want that I have to change tests if if the required behavior stays the same. Yeah? And I want to say that this amount of precision goes beyond the required behavior. And so I don't want to see that detail. I want the output to basically be less precise, to round. How do you do that in TypeScript or JavaScript? If we don't know, we'll ask Google. Let's see how to format a float. To fixed. That sounds nice. Good enough. Yeah, so let's use to fixed and give it 3 digits and see what happens. Yeah, we'll still see probably the test fail, but then it should be just 3 digits that I can just put in my test. Or maybe it passes already. Let's see. Okay, I have to put those 3 digits. Those 3, that's fine to put them in my test. So I'm going to do that. So 3 digits precision. That's good enough. Passes. Nice. Hey, but that's not yet it. Yeah. How can I get the whole size of this down? We're already at linear complexity, but I basically want to get the constant down for adding more temperature converters. I think it's too much copy paste, too much typing, and so on. How do I get this further down?
Create a class.
And what would be the contents of the class?
The interface would be from Kelvin to Kelvin. So let's create a map that the version that we have
Yeah. I first want to create the class, yeah, because I think it's correct that basically this is a pair. Yeah? And one of these functions is converting to Kelvin, the other function is converting from Kelvin. So I want that I can express this cohesion. Yeah, and then this is what I should be getting back when I look up C for Celsius, and the other pair is what I should get back when I look up F for Fahrenheit. Yeah, so let's create a class with that interface. Yeah, we say we have before I do that, let me do another step first. Let me rename my functions so that creating the class will become easier. Yeah? So when I create my class, what I have to keep in mind is what would be the objects or subclasses, whatever it is. I don't care at this moment whether it's subclasses or objects, but I care about what would be the members of them and what would be those members. Yeah, I want to find the abstraction that the members would always be the same members in terms of the contract, the interface. Yeah? So the object or subclass is then basically my subject in a subject verb object structure. And what it has to do is verb and object. So I need to find out what is the thing that varies between those pairs. And that is in this case like Celsius or Fahrenheit. And I may have to move that into the same position. And that position should be on the left side of a subject verb object structure. So in other words, in this name, I have to swap Kelvin and Celsius. And because I would then clash with the other, I have to also make sure that the to is correspondingly changed. So I have to change convert Kelvin to Celsius to convert Celsius from Kelvin. Same here, convert Fahrenheit from Kelvin. Then same thing here, Celsius from Kelvin. Oops. And Fahrenheit from Kelvin. See, that should still work. Yeah. And now my object is already almost visible. Yeah, it's a Celsius or Fahrenheit. Yeah? These are going to be my objects or subclasses. Do I really need that word convert? I think it's pretty obvious that we're converting. Yeah? I like my names to be always long enough to communicate intent. But I also like that communicating intent is not obscured by too lengthy names. And in this case, convert, we don't really need that. So let's remove convert everywhere. And in this case, it also has another intent. Yeah. For me, in this case, to and from are verbs. Yeah. Whoever is a linguist, please forgive me. But in whatever purpose they have in a subject verb noun, in a subject verb object phrase for programmers, for what we have here, to and from, their verbs. Technically, language they're not, but for us they are. I take a Celsius value and to expresses that I'm performing a conversion to Kelvin. So they are verbs. And you can already see that now in my naming, the objects and classes are starting to form. They're the actual units, like Celsius, Fahrenheit. So let's see if that still works. It does.
You go and remove the Celsius from line 1 and 5 from the method name, because the Celsius and Kelvin as parameters are pretty real. Or do you?
Well, I can't remove Celsius and Fahrenheit yet. Yeah, because right now these functions are in global scope, and then I would have two functions named to Kelvin. I wouldn't know what they are. Yeah. But as soon as I create a class, of course. So that's now, I think it's right for a class. So then here we would have a function to Kelvin. Because I don't know at that level what it is. Then I have to check if that actually compiles, or I do a mistake in the TypeScript syntax. Looks good so far. Oh, no, unexpected token. I think it's just with the function name in TypeScript, right? Not with the keyword function. And then I should be able to create instances of that class that have the corresponding formulas. This is a very special case in object-oriented programming. If you think of it, is this subclasses that I'm looking for, or is this objects that I'm looking for? It's actually both at the same time, if you think of it. It's objects in the sense that I have Celsius and Fahrenheit, and these are different things. But I have 1 Celsius and I have 1 Fahrenheit. But it also classes in the sense that both of them can do to Kelvin, but the way they do it is differently. So a different code. In traditional OOP, objects have the same code, but different data. So I want that actually the formula becomes data. How do I do that?
Yeah.
Then I still need implementations, yeah. But I can actually give my temperature converter fields that will have the formulas. What should be the type of the field? That's a conversion of number to number, right? Was that the right syntax for TypeScript? Don't necessarily remember. Okay, we'll see. And then I should initialize those fields. Here they can actually be without. Okay, let us ask the compiler.
Specify a parenthesis.
Yeah, maybe they have to be in parentheses here. Okay, no encryption. Oh yeah, and here says I need to return a value. We can then already say we return to Kelvin of number, and we return from Kelvin of, or not Kelvin, number, other. Complain that we're not returning anything. And TypeScript, in TypeScript, you have to use the this dot, which I actually really don't like. Yeah. So there's one thing where when you change design of software, you refactor, then one of the things that gives me satisfaction is that I see how the lines become shorter when I move things in the right place. And in TypeScript as well as Python with the self dot, you don't get full satisfaction from that. Whereas in Kotlin or Java or C#, you do. So yeah, this dot was missing. And that still works. Now we need my objects. So let's just create these objects. Celsius equals new tempconf, and then I can give that the formulas as lambda expressions. So that is Celsius, Joe, and then this formula. And Kelvin to that formula. And the same thing with Fahrenheit. I can always start deleting these. And then here that becomes Celsius.to. So you see now how in my name, in the subject verb object structure of my name, all that happens is I insert that dot between the subject and the verb. Okay, let's see how many TypeScript mistakes Christian did. Got lucky, and the tests passed. Yeah. Now we still have these pesky if-elses. Yeah, we still have this violation of the open and close principle. What can we do about that? We could build a nice map, right? Where we say we have the C and the F as the keys, and then the Fahrenheit and the Celsius are the values. So how do we build a nice map in TypeScript? How do we do that? And we can say it's a new map, then converters C equals Celsius. Converters, I don't know if that works. I don't think it works. I think it has to be a bit different. I think it's method put or set, right?
So there are the lists and we can directly put
In curly braces, like this.
No.
Instead of
You have it is not from that.
This way.
Yeah, so there we can directly put C equal to Celsius.
inside the code.
Inside that the list.
Ah, okay.
This kind of this one.
Let's see what it does about the trading comma. That's the one thing I think they totally missed when they defined JSON, or they defined JSON too early. They defined JSON before ES5 or ES6, whatever defined trading comma came out. They love trading commas. They just make the noise in diffs in version control much less. So that means here we should be able to say Kelvin equals converters. Will this work? Yeah. Dot to Kelvin. Yeah, and we're gonna get a different error. Yeah, I could deal with the error by first looking it up and then checking whether it's undef. I'm not gonna do that for now. Then output equals converters output scale from Kelvin. Return output, and let's see what the compiler says. Cannot find output. Yeah. Of course, it can't find output when I don't define it. I don't need to define it. I can just directly. Oh yes, yeah. Thank you. Thank you. It's not the first time I'm making exactly that mistake today, right? Very well spotted. Thank you. Passes. Yeah. how much effort is it now to add another temperature converter? It's now become almost a one-liner, right? Almost a one-liner. I still have to make this entry in converters. Can we change converters in a way that when I call the constructor of temp_conf, the entry is made then and there? Yeah. I should be able to just use the square bracket syntax and the sign, right? Then let's try that. Yeah, let's say we have a name as a string argument. Yeah, and we define the converters here, empty. And then we say converters name equals this. Should that work? It means here I have to give this a C and this an F. String cannot be used as an index type. That's what it says. What to do about that? What to do about that?
Then the type of the converters.
Should I go back to map?
Yeah, new map, I think.
Then I think it's put or something like that, with a put or set. And then here I have to call get, as far as I know. If I'm wrong, I'm just gonna go and peek. Already done that. Ta-da. Now it's a one-liner. Now adding a new temperature scale is the matter of just one line. There's still something I would change a little bit, yeah, for usability. How about we allow the user to not only give uppercase C? What about degrees C? What about lowercase c? What about the full word Celsius? And so on. So I would actually move the string from the first position to the last position, and then turn it into bar arcs. And then here just loop over all of them and make all the entries in the map. But the basic principle of being able to add a temperature converter with a single line is the same. And what I find so interesting about this is also to see that it actually shouldn't be a question of pitching object-oriented programming against functional programming and vice versa. The best results, in my opinion, you get if you combine both, just like we've done here right now. We've combined the strength of classes and the strength of Lambda expressions. We've combined them, and that gives us the full potential of our languages. Yeah. In Kotlin, it obviously looks very similar. I'm not going to show you a solution in Kotlin. So in Kotlin, you would use then an enum class, because then you can simply define the different converters as constants in the enum class, given that you don't need the ability of the user to create other scales. An enum class is non-extensible. If you don't need extensibility, then an enum class is fine. If you need an extensible design, then of course don't go for an enum. And you see the same thing here with lambda expressions. Yeah. The syntax is simply different from TypeScript because it's Kotlin, but whether your arrow is with a dash or an equals, who cares about that? And the same concept here, I'm filling a map, yeah, and just using the fact that Kotlin enums are mapped to Java enums, and for Java enums, I have a values that gives me all of the enum entries, and then I just loop over the values and map their names into a map. And then this is how the main program looks like in Kotlin. And in main, whether you do it in main or separate function doesn't really matter here. Because the key thing is changing the design in a way that the thing versus your primary change becomes as simple as possible. If you remember how much code we had at the start, yeah, and how much code it would have been without taking care of the design, fully meshing out all the converters from all scales to all scales, that would not have been sustainable. But here, every other scale is just one more line. Do you think that's also possible in C? Function pointers, and what else do we need in C? I show you. Let's see. So here, what I've written in C, I also have done a class. Yeah. Okay, they call it struct, but who cares? Yeah. I put two function pointers. That's my v table. So I can call to Kelvin and from Kelvin on those temperature converter objects. I have a list of names, and then I define my converters. And you can see they are also one-liners, even in C. I use a little bit of a trick. Yeah? I use the preprocessor because in C, I don't have lambdas. In the sense that, well, I can pass, I can do higher order programming in the sense that, yes, I can pass a pointer to a function to another function. I can do that. But I cannot write an anonymous function inside another function. C does not support that. Yeah? So I actually need to have the real functions in place, but I don't write them myself. But what happens here is I have a preprocessor macro that will then create my function. So in the first case, it's going to create Kelvin to Kelvin and Kelvin from Kelvin, and then create a temperature converter named Kelvin and fills it with the data. The only thing I don't get in C is I don't have a constructor. That means I have to build my table manually. And also in C, I don't have maps and other data structures readily available. Yeah, all I have is pointers and arrays and structs, and that's it. So in C, I'm actually doing a linear search for my converter. Yeah, which is obviously not the fastest thing to do. But it means that even in C, I managed to do this in less than 50 lines. And what I also find interesting is it's actually not that different from the other languages. Sorry, what we discussed earlier. Programming paradigms are much more about what's going on in our heads than what's going on in the language. Languages can support us. Sometimes they can also get in the way. Then you have to find workarounds. But well, key thing is one line for the next converter. Is one line for the next converter scalable? Certainly is. Any further questions or remarks?
What would you take to make the TSL hardware? I say 10 Celsius to Kelvin or to Fahrenheit?
Oh, I think it's certainly possible. Yeah. And that could be another interesting meetup topic to make a DSL for things like that. It's certainly possible. Yeah. We could have things like we could have a builder that has to Kelvin and from Kelvin as functions that take lambdas and create your actual object to register it. Yeah. This is basically a little bit below a DSL. Yeah. It's almost a DSL. It's not as verbose as a DSL. Yeah. And in this case, I think it's good that it's not as verbose as a DSL, because the problem is simple enough to say you want your solution to look like a table. We could just format this like a table. Yeah, you have only 2 dimensions. Yeah, the column, so which field in the table, and the other dimension is which row. If your problem is not 2-dimensional, if your problem has more dimensions, then a DSL will be better than my approach. Then the complexity cannot reasonably be captured in a single line. I mean, these lines are also a little bit long. And normally I don't like long lines. I tolerate long lines in this special situation. Because in this special situation, when I also format it nicely, I think I have the Kotlin version formatted so nicely already. So let's look at the Kotlin version. Here I have formatted everything in the way where you can really see the alignment. And in that special case, I'm okay with long lines, because in that special case, long lines and scrolling to the right actually makes the code more readable. But it's only because the amount of data that we need to present to understand the code or to create the code nicely fits in 2 dimensions. That's a special case.
I'm not sure about other language, but in Ruby, this is like push not like this layer, just below the DSL, you can pretty much do .c, which will convert into Celsius class, and then internally when you do Kelvin or to Celsius, and it's gonna underneath we call this.
Yeah, I haven't done it in Ruby yet. Yeah.
Yeah, we
Done it in
But that's
those languages.
That case, when you say it's gonna be one at top, it's underneath it. You do something very similar.
Did I complete this in Rust already? Yep, I did.
Prolog will be the easiest way. We just specify the component.
I haven't completed it in Prolog, I think. Let me see. I think in Prolog I just started and I got interrupted and had to do something else. That's why the file name is not even right yet. No, that's incomplete. I was just experimenting with Prolog. So if you use the right library in Prolog, you actually only have to use half of the formulas.
Yeah.
Because in Prolog, if you use the right libraries, the formulas work both ways. I think Prolog has a very bright future. I think Prolog came more early to compare to when it's gonna have its high time than I Lisp did. This also was like 7 decades too early, and Prolog's maybe a century too early. Yeah. By the way, the graphs that you had seen here, those graphs, they're also generated. If you look closely, you could have already guessed that. And yeah. Who would have thought, once we discussed the complexity, that we would be able to boil it down to a single line per node? Who would have guessed that? graphs. Are just created by that Makefile. So the Makefile uses a bash script with an array to create the digraph, and then I use GraphViz to turn the digraph into the actual picture. So that's it.